How do GPT models compare to other large language models? Have you ever wondered how different artificial intelligence systems stack up against each other? Today, we are diving into the world of large language models and focusing on how GPT models compare to others in this fascinating field. Large language models are designed to understand and generate human language by learning from extensive text data. The Generative Pre-trained Transformer models, developed by OpenAI, are a specific type of large language model built on the transformer architecture. This design excels at processing sequences of text by considering the context of each word, which helps in generating coherent and contextually relevant text. One key aspect that sets GPT models apart is their architecture and training method. GPT models utilize a generative pre-training approach. They first learn language patterns from massive datasets of internet text without specific task instructions. After this initial phase, they can be fine-tuned for particular tasks. In contrast, other large language models may use different training methods or architectures, which can affect their effectiveness in natural language processing. When it comes to scale and capability, GPT-3 is a prime example with its impressive 175 billion parameters. Larger models typically have a more nuanced understanding of language, allowing GPT to perform a wide array of tasks such as text generation, summarization, translation, and coding assistance. Other large language models may have fewer parameters or different focuses, which can impact their versatility. Another area where GPT models shine is in their ability to handle longer context lengths. Newer versions can consider more text at once when generating responses. This leads to outputs that are more coherent and context-aware compared to many earlier models that have shorter context limits. Performance and applications are also noteworthy. GPT models, especially the latest versions, excel in complex tasks like math problem solving and nuanced language understanding. They are widely used in applications such as chatbots, content creation, coding assistants, and productivity plugins that automate language tasks. Additionally, recent GPT models support multimodal inputs. This means they can process both text and images, broadening their range of applications beyond just text generation. This capability is not as common among other large language models. However, there are trade-offs to consider. While GPT-4 is powerful, it is also slower and more expensive to run compared to smaller models like GPT 3.5. This balance between performance and cost is crucial when deciding which model to use for specific applications. From an ethical standpoint, GPT models bring up similar concerns as other large language models. Issues such as bias in training data, misinformation, and potential misuse of generated content are important to address. Responsible use involves transparency, monitoring, and developing guidelines to mitigate risks. In summary, GPT models are a prominent subset of large language models distinguished by their transformer architecture, scale, context handling, and broad applicability. They play a central role in many artificial intelligence-driven tools and continue to evolve with features like multimodal input and improved accuracy, making them stand out in the field.